Today we are learning about sine waves. What are they? Can math be fun? Yes, kind of. So we're going to explain exactly what sine waves are using some very cool 3D printed demonstrations. So let's get on with the program. Sine waves are so cool and so extremely important for everything, essentially. I say that a lot. Anyways, sine waves are essentially the height coordinate of the circumference of a circle graphed versus the arc angle. What does that mean? Well, we're actually not going to get too complicated with sine waves because my audience isn't quite at that level, but they're very significant in the Fourier series in mathematics. They are partially responsible for the propagation of light throughout the universe, and they're also, I guess, partially responsible for the nature of quantum particles, which is pretty cool.
Make it simpler.
Okay, make it simpler. A sine wave is a smooth and repetitive wave shape that can be used to model various types of oscillations. It can be represented by this right here, where A is the amplitude of the wave and X is the phase of the wave. Now, sine waves are useful because they can be used to model many real-world applications, such as sound waves and electrical waves, and signals, etc., etc. It's also quite simple to analyze mathematically.
Hey, make it even simpler, nerd!
Okay, well, a sine wave is a wave that looks like a wiggly line. It goes up and down in a smooth, repeating pattern. We use sine waves to understand things that move in a repeating pattern. Like a swing at the playground. Back to you. So, we're going to get back into how we built this 3D printed sine wave representation. And technically it's more like a wave machine, but still I like to tie things in that are fun, and it's sometimes hard to tie things like sine waves into things that are interesting. So let's get into this. I did not design this. This was created by a very smart person at JBCreative. So I purchased this from him, and if you want to build one yourself, because you have a 3D printer, you can just go and purchase that from him. But I want to just highlight how cool this is. So I'm going to build this right in front of you, and then we'll go and see exactly how it works. And if you're just here for the pretty patterns that this is going to create, go ahead and skip to the end, because I'm going to showcase a lot of the cool things there. All right, let's build this. There we go. So this is the crank system that I've just built here. Now this is the reason why we get that really cool wave effect. Now this is a gear, and every time I load on one of these rings, it's offset by one tooth. So then you get this really cool looking spiral shape. And as I rotate this, that's going to lift up the individual arms that will create the effect. Unfortunately, what I didn't account for is the fact that I need to build this in place. I've built this many, many times, but I consistently make mistakes. Now we're back to where we're supposed to be. All right. So now when I turn this crank, you're going to notice this really cool wave pattern. And that's exactly the pattern that's going to be represented by these handles. Let's put those on. Then we just need to screw these back together, and suddenly it is completely built. So when I turn this crank, that off-centered circle gear ratio that we had going on along this axis, or axle, moves them up and down in a wave pattern, which is so cool. So essentially, this is the pattern that we're looking for. But it just gets cooler when we add in the horseshoe and add in some marbles on each track. That is just so cool. Okay, let's take a look at some of the ways that sine waves are used in real-world applications. And they are everywhere. Just because you haven't used them for the past, I don't know how long, doesn't mean they don't exist. They are everywhere. So let's start out with sound. You probably, if you work with the audio industry, you've probably seen a lot of these sine waves because sound is pressure waves that travel through the atmosphere. And as it travels, it oscillates. Sine waves can be used to model oscillations of sound waves, which is why it's used in audio signal processing. What about electricity? Alternating current, AC, is the most common type of current used in power transmission. That's what powers your house. That is what powers whatever it is that you're watching me on. The oscillations of AC can be modeled as a sine wave. This is a cool one. Mechanical vibration. Now, many things vibrate, like bridges or cars or anything else that has repeated vibrations. Do you remember that Mythbusters episode where they shook a bridge just by using a tiny little motor? They were just building upon the vibrations of the one before. That could be depicted in a sine wave, because anything that is oscillating, moving back and forth or up and down in a repeating pattern can be described in a sine wave. Let's go bigger. Geophysics. Now, sine waves can be used to model the oscillations of the Earth. Does the Earth vibrate? Well, yeah, earthquakes. Ocean waves. They're also used in the study of the Earth's interior using seismology. And actually, that's kind of how we think that we know what the core of the Earth is made of, just based off of how the different vibrations of earthquakes travel through the Earth and back again, which is just very cool. There are so many other fields that use sine waves, and I want you to try and find a few and mention them down in the comments below, because I want to see what I missed. Enough of the practical uses of sine waves, let's go look at something that is really beautiful. Let's head back. And I love showcasing things that show patterns or beauty in ways that I myself didn't know before. So I'm going to be switching up a few of the different patterns here and just enjoy the show.